Welcome everybody. First off, and I think most importantly, thank you for coming along to pretty much the last session of the week here at Ignite. You could have all snuck off after lunch and gone home, but you didn't. You stayed here to listen about SQL Server 16, so that's very much appreciated. So thank you for coming along. I hope you've had a good week. Hope you've had some good sessions and that your kind of overall takeaway is that it was time well spent rather than just, an excuse to get out of the office. Not that you'd do that, but I would. So I kind of get it. So thank you for that. All right, so we'll talk a little bit about SQL Server 16. We're going to talk about some mission-critical features and what we mean by that. We're not going to cover all of them, but we'll cover some of them. So I'll just get David here to introduce himself to you.
Hi guys, I'm David Lyth. So I'm a Premier Field Engineer. So I'm based out of Wellington. So I get the joyous task of tiki touring around and talking to people just like you, mainly about SQL Server, a bit of PowerShell, a bit of parallel data warehouse as well. And luckily I don't usually get stuck in the it's all broken, please make it work again. We get the luxury of coming out and talking to people where things are working okay, and we come through and make suggestions about how to make it better and point out new things that they could consider. So it's great. Occasionally we get the whole crit sit. It's all gone down in a screaming heap, but less often than the proactive side of things that we do.
All right, thank you, David. So my name's Pat, also a SQL engineer. David's in Wellington, and I'm in Auckland. I've been Microsoft since 2002, originally as a C++ developer, but these days SQL Server. All right, so let's kick into it and talk a little bit about SQL Server 16. So in terms of features and functions, what we've done is we've broken down the SQL Server 16 delivery into three pieces. So if you were to go and read about, what are the new features, why might I consider moving to SQL 16, you'd see it in one of these three high-level functions. So today we're talking about mission-critical features, which is really to do not just with performance, but performance and security are kind of key aspects of that, and high availability. All of those things really are mission-critical features. So they all play together in keeping your critical services up and performant and available. We've also got a number of features around deeper insights across data, which is the whole BI work that we're doing at the moment. There have been some tracks on that this week. Hopefully you got to see them. And then hyperscale cloud. David and I had a session just before lunch about elastic databases and the different ways in which you can stretch them, which is, up, down, and across. So there's lots of options around that. But today we're talking about mission-critical features. So we're talking about one piece of this three-piece set. And these features are split into these four high-level capabilities. So this is the way to kind of think about these things with SQL Server 16. And we just wanted to give you a very quick list of mission-critical features so that you've at least got some idea about some of the components that are coming along. And the ones that are in bold are the ones that David and I are going to drill down on and show you some demos. So we're not going to cover anything that's not in bold, other than this slide, which is briefly, and I'm going to run through it at a lightning pace. So operational analytics really is the ability to take what's called a column store index and create it as an in-memory table. So that gives you, from a performance perspective, the ability to do analytics in real time in an OLTP system, which is not a great thing to do, as some of you got to be very careful with, because mixing workloads is not a fantastic idea from SQL Server, but this is the kind of thing that helps you do that. So real-time fraud detection, that kind of stuff, normally that would be a separate ETL process. So this gives you another way to think about doing that. Then we've got in-memory OLTP. We had a session on that the other day. We've done a lot of work. Microsoft have done a lot of work. We've done a lot of work in SQL 16 around increasing the scope and capability of in-memory OLTP. You can use in-memory OLTP in SQL 14, but there are a lot of constraints. So in SQL 16, most of those constraints go away. Query store we'll be drilling into, so I'm going to skip through that. Native JSON support, which is a kind of name-value pair notation that's very prevalent now in Visual Studio and in Azure. So there's support within SQL Server to manage JSON protocol messages. Always encrypted, really cloud-driven, but a very kind of important part of SQL Server to keep data encrypted all the way from the client through to the server and back with all parts in between. And the key here is that the keys are kept at the client and managed through the driver. So what that means is you can have your data encrypted in every other piece of the data flow all the way to Azure and back. So, this is something to think about with cloud-based deployments. Then we get to row-level security, which we're going to talk about, so I'm not going to go through it now. The same with dynamic data masking. Let's skip to enhanced always on. So always on is a high availability feature. It's been around in SQL for a little while now. Very popular, very useful. From my perspective, one of the best things that happened to SQL in a long time is the ability to read in a very easy way with low latency from your secondaries. It's an awesome feature that solves a lot of design challenges. So that's still there. There's round-robin load balancing of replicas for something called read intent routing. If I want automatic redirection of my read requests. So maybe I've got reporting services or my clients connect to the primary server. I don't want my reports to run there because it's going to lock and block my throughput of my OLTP traffic. So this will, behind the scenes, dynamically migrate that connection to my readable secondaries. And that's now done in SQL 16 with a round-robin capability. So that's awesome. Automatic failover based on database health. In SQL 14, if one of the databases in your 4-database availability set goes offline, it won't fail over the group, the availability group. You can set it to do that if you want to in SQL 16. So that's a big change. DTC is now supported in Always On. There are some customers that have really been unhappy or they can't do what they want to do because DTC is not supported. Lastly, scalability. Windows Server 16, 12 terabytes of memory. So 12 terabytes of memory supported in the OS, and we've got in-memory OLTP. So you can imagine those two things kind of going together. So that's a real fast drill down, just in the interests of time. So we're going to talk a little bit about Query Store. Query Store is a really fun and interesting, I think, implementation in SQL Server, which is really to do with automatically fixing any type of plan regression that you might see. Or you upgrade an application from one version of SQL Server to another, and because of the way the optimizer works, and because of the way plans can change underneath the optimizer, you can end up with a new plan when you do an upgrade. And that doesn't always end well. Sometimes the plan is not as good as the one that you had before. There's a thing called parameter sniffing in SQL Server, which makes SQL execution plans very sensitive to the parameters that you pass in when you call stored props. So this is a way to kind of manage that plan regression. So this is some of the things I can do with Query Store. It keeps all the plans for a given query. So those plans are kept, right? They're kept around over time. It survives a restart, for example. So right now, we use things called dynamic management views or DMVs and a plan cache to store all of that data. But it's not persistent. If you restart your server, it's gone. So this is a problem that's really solved quite neatly by this Query Store. So it will show you any queries that are regressed. You can see what are my most expensive queries, what are the things that are running really slowly, what are the things that are using time right now, and what are the queries that maybe I should choose a different plan for. Because I can say, use this plan and not that one, which can be quite handy. Yeah, something to consider, and force a better plan. So Query Store is keeping the plan store, so it's keeping all these plans that we talked about, and it's also keeping runtime stats of queries that have been running in your SQL Server. So it knows at any given point in time, what are my 10 most expensive queries? And there are lots of ways to get that. It's not, that this is magical information, but it's very readily available in a graphical format, and it survives a restart, and it's per database. So that makes it more useful and less difficult to extract this information. So it makes performance troubleshooting a little bit easier. And there are configuration settings around the Query Store that determine how often that data is flushed from memory out to the Query Store database. So because of the performance overhead of tracking this data. So this is a key aspect where it can help you, and David had a session earlier in the week about upgrading SQL Server. We're talking a lot about SQL 16 this week. It's in CTP, things are still changing, and there are a lot of you in the room with, older versions, some with quite older versions. And you need to do an upgrade. And one of the things that stops you, the main thing that stops you is vendor support, in reality. But another thing that might stop you is your kind of risk mitigation. What if things get worse if I install a new version of SQL Server or I do an upgrade? So this is one of the things that can mitigate that risk. You can set the compatibility mode of the original version of the database, bring it into your new environment, run query store, do some baselining, come back and choose the plan that's worked the best for you, use that plan and then upgrade the compatibility mode, and use the query store to monitor whether there's any regression. All right, so it's handy from an upgrade scenario perspective. So there's a quick view of it. I'll show it to you very briefly and we'll go through it, but this is really what it looks like. But let's move through that. So it's a feature that you turn on and turn off. It's a per database specific feature, which, as I said, I'll show you. So you turn on Query Store, and now it's tracking all the queries against that database. And it has a graphical interface to allow you to look at and choose the plans that you like for that database. So all of this stuff we've had, but not in a very kind of readily and easy way to use. So this makes it much more useful. Live query stats, which again I'll show you, is a way to look at your query while it's running. Right now you have to wait for an execution plan to complete, and then go and look at how that query ran. So we'll see how that changes things. But you'll actually see a lot more when it's running. We call it marching ants, which is you'll see kind of why that's the case shortly. It's quite an interesting concept. So let me just show you a little bit of a demo around that. Thank you, David. Number 5. Yep. Check that we're on the right thing here. Yep. Yeah, so what we've got, let's look at, I'm going to show you Query Store. So here's a Visual Studio app. This is the second time today that I've been in Visual Studio, which, it's really uncomfortable as a DBA in this environment. I definitely need a shower now after being in here twice, but, bear with me. We'll kind of make it work. But it's an interesting set of code because what the code does is it randomizes writes into a table. And the reason it's doing that is to create a data distribution that's sensitive to the actual values that are used in a stored prop. And then it kind of pins the bad values. So what this allows you to do is actually create a little test rig that creates 2 plans for a query by manipulating the data distribution and by the calls that are made. So we'll go in and we'll try and get this thing up and running. So I'm going to have this sitting in Query Store. And we'll run this demo. And now it's running. And it's running this query that's randomizing all this data and calling all of these stored props. So we need to, let that run for a little while. And then if we go into our Management Studio, what you're going to see, if I shut down some of these databases, you're going to see this Query Store. So Query Store is sitting as a demo database. It's already been set up. It's per database. So I've already pre-created it. But you go into any database that you've got and you turn on Query Store. So if you look at the properties of the database today, you see that it's got a new thing here at the bottom that isn't in your current version, which says Query Store, right? So you go into Query Store and you change all the settings here to support Query Store. You turn on Query Store. You say how often things are going to be flushed to disk. What's the aggregation interval? Because as these counters are collected, it aggregates them for stats and display purposes. So this is where you manage that, which is managing the overhead that Query Store is placing on that database. Because always it's a balance between the overhead and the measurements that you're taking, right? So this is where you enable this. And now we're actually running, and we can go in and you'll see our Query Store. And if you were doing it, you can also do this through T-SQL. Here's your database, and you set Query Store on. Run a table, create this table, and run all of these queries. There are lots of DMVs. I'm not going to run them all. We've got a lot of demos and short on time. So different DMVs you can run against the query store. So if you don't want to look at things graphically, if you want to collect it in a different way, there are query store DMVs to support that. But we're actually going to have a quick look now at what's going on graphically. So what we see here is query store. So query store appears. This query store has appeared in this list because I've enabled query store for a database. So if I'd enabled it for a different database, query store would turn up in that view for the other database. So as soon as I turn it on, this turns up. So what you can have a look at and see, well, what are the kind of things I've got here? What are my top resource-consuming queries? So what this does for me is it lights up Query Store within Management Studio. So it's built into Management Studio. All you need to do is turn it on, right? And I can look at things over time. What's the average duration of my queries? I can hover over and see particular queries. I can see what the stats are, what are the kind of resource requirements for these particular queries. But what I want to do here is I want to show you the ones with the number of plans. So what we're interested in is this test sample that I ran because it generated 2 plans. All right, so these 2 plans, they're running because my sample's still running, these plans are still being used. And one plan is a lot better than the other plan, and you can see that by looking at the graph because the y-axis is the duration in milliseconds of running this query. So one of these plans isn't so good, and the other one's a lot better. And as you kind of march through time, you can see that moving on. So here we move on, we see it kind of slightly moving on. So what I might say as a DBA, I might say, well, show me both of those plans. So that's one thing that I can do. And what you see here are the 2 plans, the one that was a good plan and the one that's not so good. And for those of you that have done a bit of work in this area, a RID lookup as a nested loop against an index seek means that it's had to take the index. The index was not what's called a covering index, so it doesn't contain all the columns that the query asked for. So it uses the index for some of the columns, and it does what's called a RID lookup because this is a heap table. Hopefully you're not going to sleep at this point. And gets the rest of the data and then uses a nested loop to bring it back together. Right? That's one of these queries. And the other one is just doing a full scan of the heap. Right? Following this IAM pointer chain to all of these records. Anyway, again, sorry about the time here. So I like this plan. I like plan 1. So I click on plan 1, and what I can do here, I can say, I want to force the query to use plan 1. So what I've achieved now is I've said every time this query runs, until I tell you different, I want you to use this query plan. That's actually pretty useful. That's a pretty cool thing to be able to do. And I don't have to do it through the GUI. I've got full interface to T-SQL to do this. And I'm watching it over time, right? So here what happened is bad luck. Data distribution, parameter sniffing, the first call wasn't particularly a good set in terms of the table itself, so it picked a bad plan, and now I've shifted it out to the other plan. So that was it. That's probably a super lightning covering of Query Store, and you've seen, I've just kind of scratched the surface of it. The guys back in Redmond and other engineers around the SQL community, this is the feature that everybody's pretty excited by. It's really quite a nice tool. We'll go through to the end, I think, and then we'll take questions because we're just pretty, we really are pretty shot for time here, so apologies for that. All right, so I'll show you one last thing here, which is this live query stats. And really, there's not a lot to it, but it's kind of fun. It's a fun implementation. If I can get my mouse to work. There we go. So what I do here, I just run a query, and I'm going to turn on live query store, or live query statistics, I should say. And there we go. Marching ants. Right? Go on, it's pretty good. Come on, guys. It's not bad. So what we're seeing here is you're looking at each individual operator in the plan as it's running. The reason I think this is very useful, apart from the visual kind of fun of watching these ants wander up and down, is you really do get to see where the blockers are. Because some of these operators are going to finish a long time before others. For this particular plan, it's the sorts. Because sort's expensive. You shouldn't really sort in SQL. Right? Not at this level. You should find other ways to scale it out. But you see this in a very real way in the live query stats. So you kind of watch which ones finish. You also get the real feeling of how parallel this plan is being run too, right? of how the operators are streaming data out while other operators are taking the inputs. So it's fun and it's useful. All right, so let's move back to...
Yep, and you need to ask a question.
And I need to ask a question.
Give stuff away.
David says I need to give away some prizes. So my question is, how do I get to that query store GUI? What are the things I need to do to get to it? Properties, a little bit more, and then enable query store. And then what was the last thing I had to do to actually get to the screen itself once I'd done that? I'm being mean. You're kind of okay. I had to right-click and ask for it, but that's all right. So let's move on, and I'll pass over to David.
Okay, next cool feature. So temporal database. We weren't allowed to use a word starting with T that's owned by BBC Wales, so we'll just call it temporal instead. So why do we need temporal? So it's a time travel feature. So we would really love to know, what did the data look like an hour ago, a day ago, a week ago, last month? And for anyone who's ever been in support and had an app support person come up to them and say, I got the where clause on my update wrong, can you help? This is perfect for that. Or the delete. Predicate missing on a delete is always a favourite of DBAs. So, really cool feature. So, how do we get started with it? First off, we create a temporal table. So this is just a table that we're putting a few extra bits and pieces on. So it can be your main transaction table. So we're using an alter DDL statement to do that. Once we do that, all of our DML that we've still got for that table stays the same. So we can do inserts, updates, deletes. They all quite happily work. And then a bolt on the side is temporal querying. So we can still do bog standard select from table name, but we also get an addition for system time. And we step through some of these options for what the qualifiers for system time are. But so you can do a query and specify time parameters for that. So no change in your normal activities on that main table that you're working with. So how does that actually work? So we've got your actual data table, the temporal table. So this is your person table in your database that's sitting there. No change there. So all your updates go into there. When you're doing something that's changing or inserting stuff into that main table, we've then got activity going on to say, we want the old version to go into a history table. So that's a store of all of the before images of every record that you've got. And that grows. So if you're doing just a normal query, select from table name, works just as it always has done, pull stuff out of that table. If you're doing an as of system time query, then it's joining your two tables, because your data that you want as of time may still be in your main table. It may never have changed. But it's then going back to your history table and saying, what are the records that are relevant to the time period that you've given me? Puts those together and brings them back to a result set for you. So just as a quick walkthrough, so we've got a department table, and it's got some history. So the from and to are the key bits that enable this. So they are valid from and valid to fields for each of those records. So the top ones have got a valid from, and the to is infinity. So that's the current record there. And the history ones are delimited with an end date on them. So the options that we've got, obviously we can do just a normal select, and it will pull out our current time records. So we've just got whatever's in the main table. So that's that. If we do as of 1st of January 2006, then we're going back and saying, what were the records and what did they look like on that particular date? And again, this is based on a union of those two tables. So we've got 8, 1, 2, and 3, and it will pull out those values for you. If you're doing a between, so that's any records that existed between those times. So it's pulling out all 5 of those records, because all 5 of those have existed in that time span that you've given. So you may well end up with what you think are duplicate primary keys in there, because you may have a record that's changed over time, and if you give a between range, then you will get all the variants of that record. So you can think of it as versioning for records. And contained in is another variant. I think it's in the standard, but I haven't thought of a good use case for this one. So this only pulls out records that started after your time period begins and are time-bound before it finishes. So they've born and they've died in that specific period. So if anyone can think of a good idea, I think that's my question for the end.
It's a clue.
No, it's not a clue because I can't think of any. And this is a lead into sort of using 2 different features together. So the history table will quite naturally grow, and especially if you've got a really active table, it'll start growing much bigger than your fact table that you've got there. So we talked about StretchDB. So one solution to this is combine temporal with StretchDB, stick the coal end of your history table in Azure, and Bob's your uncle. So just saying that if you grab that, it'll go through and work out which of those stores your actual data that you need is in. And there's a couple of different qualifiers. Between is the thing that we saw of saying, is it bound in this time period? And we missed one. There's one variant of that, which is a little tiny variant about the edge cases of if you've got the end of the time period. I think between was the one that excludes the end case, and then there's another clause that you can use if you need the boundary included in your data set. So we'll have a quick look at temporal in action. Specified module could not be found. Cool. We'll get rid of that silliness because we don't need the Crown Plaza, because this is not doing any hybrid at all. So first off, we use our old friend AdventureWorks. Yeah, right, all right. Go away. Pat, what have you done to this? You've got Visual Studio on here.
I think that's the cause of all grief, actually.
Yes. Do you need Visual Studio anymore?
No.
Right. That's this thing, isn't it?
Yes.
Die. Right. We've done our SQL DBA bit. Can we...
That's it.
Yeah. I struggle with the hover bit. Okay. So this is just the syntax for creating a new temporal table. So we're able to either create a brand new table and put temporal on it, or our next section is you can alter an existing table and add the bits and pieces that you need to make it temporal. So this is just saying that we've got a couple of columns at the end of our table. So this is our customer table. We've got these 2 sysstart time, sysend time, and they're generated columns, and they're the things that are being used in that system time period at the end. So that's the magic that makes temporal happen for this particular table. Yep, and Pat's already run that, so that's cool. And this one is creating a history table. So again, these things come in pairs. You've got the main table and you've got the history table. You can either create both of them at the same time, or you can, if you've got an existing archive or history table, you can amend that and join it to your primary table as well. So lots of flexibility. See, yeah. So we'll just stomp on through. And this is just the example of altering the table if you've got an existing one. Yeah, so that's already been done. And this will do the same thing. Hey! So this is just showing we've got our history table, and we can quite happily just treat that as a normal table and pull some records out of it. And this is the normal temporal table. So we just pulled things out of there as well. So now we go and pretend we're an application support person and go and do random updates in our table. Not that application support people are evil, but... Oh. Damn. Let us change that, because I think we haven't... Sorry, guys. Yay. So now we've got a whole bunch of stuff in the history table, and we've got the sys start time and sys end time wandering down here. And you can see that Pat's clock is on a funny time, which is why we've got some funny sys end times on there. So we do have some details here where we can go in and look at DMVs to pull out information on temporal tables. How are we doing for time? Well, we sort of
5 minutes.
Yeah. So we can quite happily interrogate the system about what's going on. And if you need to know what the columns are, all those exciting things, you can quite happily grab those. Now, we set it back to 19, didn't we?
Yep.
Yeah, but this is,
Yeah.
we changed it back. So we changed it from
19 to 17.
19 to 17, so we've got no rows with 19 on it. But now, if we go back a wee bit, so we are now on the 9-03. Yay. So we've gone back in time and said, yeah, we really did have some records that looked like that. Obviously, if you're doing this, you do exciting things like build in a date diff to work out 10 minutes ago rather than trying to remember how to hard code times into things. And so we can do this thing as well. So that's your contained syntax. So that's from 1 minute to 2 minutes ago, and that's not actually pulling anything out because I've been faffing around with the SQL here and nothing actually got changed in the last 2 minutes. But that's the idea that if it would change that to lots of numbers.
Then we shall move on, I think.
Yep. No, failed. Okay, so that's the idea of temporal. So yeah, a real time travel view of your data and the ability to have a history table that you can then really easily go back. Yep. Not unless you're actually storing that in a field in the table, no. So it's not SQL audit. Yep.
So all of those questions about data and schema change, they're audit related.
Yeah.
So this temporal stuff is more scenario based. You know, fixing data that someone broke. Think of dimensional modelling. You know, change data capture, new rows, deltas, ETL deltas.
Yeah, but there is a slightly different answer to the can you add a new column to your table, and there are some constraints around that at the moment. So the Books Online has got quite a bit of documentation around that. So there are some constraints around what you have to do if you want to add or delete a column. So it's not just straight DDL. But again, the stuff is all in CTP. And if you guys think that that's a real constraint, they're quite happy to take feedback and see what they can do about that. So we would encourage you guys to have a play with the CTP and give them some feedback about that.
Yeah, I just want to repeat what David just said about encouraging feedback. It's quite unusual for us to be given the go-ahead at an event like this to showcase CTP2 features. So we definitely hope to get some feedback from you folks around looking at some of this stuff, because it's all part of the process.
So very quickly, did anyone have a good use case for the contained?
Financial fraud detection. We're looking for a row that's then entered and disappeared. So we have a dodgy GB, put the payment in, and then it disappears.
You could give it to him, but I think he's got a bit of a UK accent, so I'm not sure that you should. But
You think he is a fraudster?
No, let him have it. I think it's highly likely. Oh, okay.
That's even worse.
You mean you used to be in fraud and now you've moved on, right? Okay. All right, thank you, David. So let's talk about our next feature, which is row-level security, which has been around in, let's say, some competitor products for quite a while. And it's a request that often comes up. How can I protect rows based on who's asking? Is the basic scenario, right, that you're trying to support. So this allows you to do that, and it will be interesting again to get your thoughts and your feedback. Maybe not today, but there are formal ways to do this. And we will be here after this session, by the way. We're going to join the Microsoft stand for an hour and have a beer. So if anybody wants to come and talk more about SQL, we're only happy to do that. So row-level security. So how do you prevent unauthorized access from users to a specific table? And it's been a challenge forever, right? And you can do it. People do it. They use views and all kinds of code to do it. So it's not that you can't do it. It's how much effort and how much work do I need to do to supply this kind of enforcement. So some of the benefits, maybe you'll do it in a cloud, in a multi-tenant type deployment. You don't want tenants to see other data that don't belong to them, which they won't be able to do anyway, but here's a place you can do that at the application tier. So this is kind of one scenario, and I'll talk about a few more scenarios where that may be useful to you. Row-level security working at query time. No client application changes needed. So this used to say no application changes needed, and I put the word client in there myself, and there's a reason for that. You need to make database changes. You need to write T-SQL functions to make this work. And some people consider that to be an application change. So it just depends how you've structured your architecture. So it's not zero footprint. There are changes that you need to make. But your clients don't change. The changes are in your database code, which is where they should be. Right? So centralized security logic inside the database. So it doesn't matter how other people access the database. Right? It really doesn't. You protect it in the database from any client that most connect. I remember being a DBA about 100 years ago, and the DBA I was working for said to me, I don't want anybody at any time touching any of the data in my database. I thought that was a bit excessive, because that if nobody ever gets to see the data, it kind of reduces its business value somewhat. But it was kind of a good way for a good start point for a DBA, I thought. So putting it in the database is a good approach. So some use cases, rather than just code, because the demos are quick and you'll go away and think, well, what was all that about? How can I actually use the stuff? So the demo that I'll show you is a hospital where we play doctors and nurses, which allow nurses to view data, but only for patients that they look after. So that's the scenario, right? So if it's a ward that they own within a time frame that they were responsible for that patient, then they can see the data. Otherwise, they can't. Some other scenarios, a bank. You're able to see financial data based on who you work for or what branch you look after, or maybe your role within the company. I mean, there are lots of scenarios for the who can see what problem, right? And the last one we've already talked about, multi-tenancy in a cloud deployment. So concepts, how do I actually get this to work? There's the code here at the bottom is this is the key. So you have a predicate function. user-defined inline table-valued function, an ITVF. It's a T-SQL function that in terms of the syntax and the semantics, it returns a table. So you have a function that says these are the rules around who can see what. Then you use a thing called a security predicate, which is this add filter predicate, and you essentially add that filter predicate, which is the function that you've written, to a table. So I want to add this function as a gating mechanism to DBO patients as this security predicate. And I can add multiple predicates to the same security policy. So I could have one security policy with 10 tables referenced as security predicates. And that's managed by your security admin. So your security admin is not going to write the T-SQL code because he's probably not the kind of person that would do that, but he is going to tell you what the rules are. So your DBA and your security administrator, if you like, would really work together to implement this. Okay, this is kind of how this is going to work. So there's my predicate function. It has a name. You give it a name. It really shouldn't be in DBO. We'll come back to that. And then you add the filter predicate to say this is the predicate I'm placing on this table. In Books Online, what we say at the moment is once it has a filter predicate, you can't add another one. It won't work. That actually needs updating. It will replace it with the new one, and we'll see that. But you can only have one in effect at any point in time for a given table. Okay, so this is how this is working. And then my security policy is a collection of these predicates. So I want to protect 6 tables. I write 6 functions. I apply 6 security predicates to 1 security policy. Are we good? You kind of see how that's working. A little bit of an example in terms of the code. So here's a function. Here's my predicate function. And this function gets applied by anybody that tries to read from this table, right? If I do a select star from this table, the optimizer is going to change the query to add a where clause to call this function, right? So now I'm only going to get back the rows that I'm allowed to see based on some business rules that have been set in my database tier. All right? So this is kind of what I'm doing here. This particular one says select one, which is yes, you can see the row, basically. So you can select the row if the current user is a user that's available that's also joined to the employee table and that they're also able to see the wing for the hospital that they've asked for. So there's 3 steps. Step 1, your policy manager or your security admin person creates the filter predicate and the security policy in T-SQL. No, I wouldn't entirely agree with that. I don't think the policy manager is necessarily a database person. This would be the policy manager in conjunction with a T-SQL person that's going to do this. And they'd write these functions. These are the rules. And then once the rules have been written, then you just use your application. And a nurse might say, give me all the rows from the patient's table. No one's told her that this is bad for performance. She just does it. Go and get all the rows from the patient's table. And under the hood, SQL Server is going to apply this predicate function, right? So this is going to happen, thank you, David, this is going to happen automatically. So you can imagine some performance impacts here too, right? Because we started out with a query plan that was probably a scan, and because we selected all the columns, it wasn't an index scan, it was a table scan. Bad nurse. And then what's going to happen, these predicates are going to get applied, and that query plan is going to change completely. We're going to get 3 or 4 tables referenced with some nested loop joins. So there are performance implications of plan changes of when you do this. So it's something that you would test very carefully. Yeah? All right, and then we'll get on and have a quick look at this row-level security. Thank you, David. We'll just spin across to there. Perfect. All right, so here's our row-level security. I got a little reset just to kind of put everything back to scratch, which I've obviously already run, so that's fine. That's all good. All right, so I'm going to use a database, which is a hospital database. Here's my hospital database. And I'm going to say, give me all the rows from the patient's table. It's my laptop, my game, my party. I'm sysadmin. I'm DBA, right? So I get to see everybody that's in the patient's table. So let's go and have a look at those rows, and I get to see them all. All right. this is kind of a point of contention, and different DBAs have a different perspective on this, right? There are DBAs that say, yeah, I should be able to see all the rows in the table because I need to know about this data in order to improve what I do. And there are other DBAs that say, no, you know what? This is a security thing. I don't want to know what's in the tables. I shouldn't be able to do this. And I don't have a comment on that, but there are definitely two perspectives around that. But anyway, right now I can see all of the patients in the patient's table, which is not a good thing, at least from this demo perspective. So what this demo is using, it's using database roles. If you folks have used roles before, you create a role in the database. You just create a role and you add members to the roles. You add users to the database roles. They get something called a database principal ID that maps. There are some T-SQL system functions to show you which role you're in. And we've got doctors and we've got nurses as the roles in this hospital database. So we'll have a look and see, well, who have we got? What are the employees and the roles that we have right now? So we've got various nurses like Florence Nightingale and various other folks and people in different roles. We'll also have we'll have a doctor in there somewhere as well. So we've got a few doctors. So that's our kind of test database. And we've said, well, you know what? We don't like the fact that anybody can see all of these patients. So we're going to add row-level security to this scenario. All right? So the best practice, what we at Microsoft are recommending, is that you put these objects in their own schema, which is why we've got create schema here, which is why I said I didn't really like the DBO on the slide. We kind of prefer this to be somewhere else, right? So you create a schema. It's going to be our security schema, so we'll do that. Hopefully it's not already there and the reset actually worked. And here's our predicate function, right? Here's our predicate function. So we can see that we have the wing coming in, what wing the person's responsible for, what the start time and the end time during that responsibility, and then we're joining those two tables together. So this is our business rule. So somebody has said to the DBA, hey, can you make me a business rule that looks like this, please? And they've gone away and done it. So you need something to hook into, either database role. Some other companies use other things. I've worked with Telecom now, Spark, for example. They use a thing called a T-number. And other companies have other things within their database schema that they hook into. Maybe it's a staff ID or something like this. But this is where you kind of hook this functionality together. But we're just using database roles here. So we've added the function. Now we need to say, create the security policy and add this filter predicate. So we go and do that. So we've now implemented row-level security on that table. Right? So now I'm going to select the same table that I could select from before where I saw all the rows, and now I can't see any rows at all, even though I'm sysadmin DBA. That's the key takeaway here. I think this is a good thing, but not everybody thinks that. But if you do think that, you can do this, right? The sysadmin shouldn't necessarily see everything. So we've turned this off. So now we've got row-level security going. And we could have a look. We can execute as some of these other users. I'm just going to do it quickly for you here. And depending on who I am, whether I'm an admin or whether I'm a nurse, I'm going to get different things back. Let me just do that one more time. Probably selected too much here. It's kind of cotton top is moving. And you'll get different outputs depending on who you are. So just kind of trust me on this. It's showing me the right rows depending on that table join. Yeah, so that's kind of some of the things. If you wanted to, you could use more involved predicate functions. So here's a slightly more complex one that says, okay, I do care which role you're in, but I also care about the wings you were working on is relevant. And if you're a doctor, if you're in the role of a doctor, is member as a SQL system function that works with roles. Am I a doctor? The person that's running this query. Yeah, then I'm going to let them see the data if they're a doctor, and they're also asking to look at Wing 3 because doctors are in charge of Wing 3 in this scenario. So that's the kind of thing that you can do here. Or I can say if I'm an admin, I always want the sysadmin to see the data. So if you're not in the camp I spoke about before and you do want the DBA to see it, well, you can still do that. It's not like it's an either-or scenario. You can support both. So this is the concept, and if I wanted to do that, I'm not going to run through it all, I'll just kind of take you through it. I could replace that simple function that I've written with this more complex one by saying, well, now add this filter predicate 2, and it will replace the previous one. Right, and now every time my code runs, if you look at the plan, right, let's have a look at the execution plan, because that's always fun. Let's include the execution plan. If we turn off, this turns off that RLS that I've just implemented, and what we're going to see is a plan change. So select star from patients. I guess you all would be pretty familiar with the kind of plan that would generate, and you'd be right. A clustered index scan, which is a table scan, because a clustered index is the table. So this is a table scan, and we're looking at all of the rows. But the point of this little brief demo is if I turn it on, if I turn RLS back on, we're going to see a very different plan. Before we saw our clustered scan, our clustered index scan. Now I don't see any data, and I see a very different plan. I see all 3 tables are now involved in the query, together with a nested loop join. Right, so very fundamentally different way, because SQL Server has it's modified this execution plan at runtime to call my inline TVF. So you do need to do a lot of testing, a lot of optimization, and do this with care, because you're definitely changing the way that SQL is retrieving these rows. But what a great feature to be able to do some row-level security at a fairly minimal cost. Yes, you need to write these functions, but now that controls all access. That supports any access to that table, right? So I do think this is a feature that's worth exploring further. And I think that's pretty much it. So we'll switch back.
Yes, and you need to ask a question to give away.
Oh, my God.
Yes.
Well, you all know what question I'm going to ask you, because hopefully you're awake. Should DBAs be able to look at all the data in a table or not? Hands up to ask. And you need to give me a bit of supporting evidence. So I'll go in the front here. I really, 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 really like that answer, so you can have it anyway.
Coles. Okay. Pat's left me about 5 minutes to talk about our last feature. So dynamic data masking, which is sort of like something out of Zorro. But very briefly, so dynamic data masking, the use case is you've got customer services reps who get a screen. They need to see part of the credit card number that a customer has, but they shouldn't see all of it. So lots of other use cases, but that's the traditional one, and we won't talk about security numbers because that's an American thing. So what do we do to start off with? We've got our ubiquitous security officer, and they're defining a mask to put onto these columns. And there's a couple of different masks available, and there's also an unmask function that you can use. So you grant unmask to someone who should be able to see all of the data in its full glory. So the user grabs the stuff from the table. So your other login will obey those masks. So you've got the social security number column. Your login that's seeing the masked values, just getting a couple of characters at the end. The rest is masked out with rubbish. And same with the email one. But your admin 1 is actually seeing all of the data. So being able to work through it. So we've got a partial match mask there. So saying that we'll just pull out one character at the start, replace everything else with X's, and in this case, 0 trailing characters pulled out. So you'll only see one character. A default which looks at your data type and applies a default mask for you. So there's a couple of things there. One of those ones are random. And an email one which gives you the first couple of characters and whatever the dot extension is at the end to allow your CSRs or whoever is looking at those to be able to get a hint as to what the thing is and not know the whole thing. So again, just going through and running alters to add that mask. This is just some code so we can quickly run through the demo on there, which is where we're up to. Thank you, Pat. Pat's kindly prepared the demo for me. So we make sure that we have actually dropped the tables and they're not there. Where is that window? Whoa. Yep.
Can you do these granting and not granting masks via a role?
You should be able to, by a group at least, because you're granting that to a user by security. So yeah, I haven't tried that. But certainly the mask is on the field in the table, and then the unmask is against a login. So if we just create quickly that. Then drop down here, CTP, there's a few trace flags and things needed. We're hoping that they won't be in the final release. So again, we're just doing alters, adding the mask to these fields that we've got. Dump some data in, and just do a select to prove that we do actually have some data in. It sort of looks like what we just inserted. This is creating our low-level user. And just saying that because those masking functions are there, then this low-level user will just see those masked versions of the data that's in there. Then if we do the same thing and actually grant that unmask, then they see the whole thing. So all of the data is still there in your table. You're just putting a mask so that at runtime, what's coming back is either masked or unmasked. Yeah? This is a per field. Oh, so you're talking about the unmask or the... As far as we can see there, it looks to be database-wide. So you're granting that and they see everything. So you'd expect that that's something that you're giving to either an admin or to an account that's acting as a application service account or something like that. Yep.
What point do I select into, and I've got the data mask, so I extract the data in that table, put it into a table.
Great question.
Yes, and
Great
right
question.
now, if you do a select into, that's a different field. It doesn't have a mask on it, so you see it. But if you don't like it, give the guys at CTP feedback.
So that, just in case everybody didn't hear the question and to repeat the question, what happens to data that's done with a select into? So it's masked, but you select it into another table, can I see it or not? And there have been a lot of internal discussions, a lot of feedback about that. It's not obvious which way that should fall. So that's still working through the CTPs, but it's a good question. Right now, David, if I'm not wrong, you do see it. Is that correct?
Yep.
So can I assume then that anything to do with OLAP does not have any of this?
We don't have OLAP anymore. Sorry, mate. No, I'm kidding. So, no, these are not OLAP features. These are just engine features. Yeah. But there'll be a whole load of new stuff relating to cubes. You just went to the wrong session. I lied. We didn't have a session. All right, let's move on, David. We better move on.
Yep. So,
I'll flip you back.
yes. Well, that's my lot, Pat.
Oh,
it's
right,
yours.
I'll move on then.
I will take this back down to the man who asked about the select into.
Definitely.
Yes.
He deserves two, actually. But here we go.
But we haven't got to.
All right, so just by way of a summary, not only of the session, but really of the week, I really do hope you got some good stuff out of it. David and I have done quite a few sessions, but there have been lots of other sessions as well. Really appreciate it. Definitely appreciate it, especially last thing on a Friday. Bit of a takeaway here just to remind you what the new features are and to call out again some of the features that we talked about. And also a last thing that will be around for an hour or so. There are resources you can go check and look at around all of this stuff. Please be aware of our Premier Support team. We have a lot of Premier Support offerings in the team that David and I work for, which is Premier Support. Lots of teaching of all kinds of health checks, lots of services that that we can offer. That's my sales pitch. Do the evals, otherwise we don't get invited back, which might be a good thing from your perspective, so just decide. But enjoy, have a beer, enjoy your weekend. So, thank you. Cool.